Hi. OCR 2022, AS Level, Chemistry, Paper 1, Breadth in Chemistry. In the fixed comment under the video, I leave a link to my website jctnotes.com where you can see the written answers to this paper. We start with Part A, Question 1. We are asked which substance has a giant covalent lattice structure in its solid state? Potassium, silicon, sodium chloride, or water. We know that the potassium is a metal, therefore it has metallic bonding. The silicon is a giant covalent structure, the same as carbon in diamond. The sodium chloridine is a salt formed by ions, therefore it is ionic bonding. Water is formed by polar molecules, formed by covalent bonding and linked by van der Waals forces. Therefore, the answer is B. In question 2 we are asked what is the meaning of the term electronegativity. We are given 4 possible answers. Electronegativity is defined as the ability of an atom to attract the bonding electrons in a covalent bond towards itself. Therefore, the answer is A. In question 3 we are asked which of the 4 compounds given is an alkali. In option A, the COOH is a carboxylic group, therefore, it is an acid. In option B, the OH is an alcohol group, this is not an alkali. In option C, we have nitric acid. It is a strong acid that provides protons. It is not an alkali. In option D, we have ammonia, that is a known alkali. It provides OH- in water. Therefore, the answer is D. Question 4 asks what is the number of paired orbitals in a sulfur atom? 4, 6, 7, or 8. Sulfur has 16 electrons. 1 paired electron in orbital 1s. 4 paired electrons in orbitals 2s and 2p. Another pair in orbital 3s. We are left with 4 electrons in orbital the 3 orbitals 3p. The first 3 electrons will go to each orbital, and the 4th electron will start pairing. If we count the number of paired electrons, we have 7 pairs. Therefore the answer is C. In question 5, we are asked which of the following elements have the lowest melting point: sulfur, phosphorus, chlorine, or argon. As the argon is a noble gas, it is going to have the lowest melting point of these elements. The answer is therefore D. In question 6, we have a table with the first 4 ionization energies of an element of the period 3. This element is reacted with chlorine. And we need to find what is the formula of the chloride formed. Ionization energy is the minimum energy required to remove the most loosely bound electron of an isolated gaseous atom, positive ion, or molecule. In this problem, we are given the energy to remove successive electrons from an atom. More important than the value itself, is the difference between successive ionization energies. We can see that the difference between the first and the second ionization energy is around 700. The difference between the second and the third ionization energy is around 6000. And the difference between the third and the fourth ionization energy is around 3000. Therefore, the additional energy required to remove the third electron indicates that this electron is from a deeper layer than the valence layer, and the valence layer has 2 electrons. We can consider that we are forming XCl2. The answer is B. In question 7, a sample of lead sulfate is decomposed by heat to form lead sulfite and 2.4 grams of oxygen. We are given the equation and the molecular mass of the lead sulfate. With the molecular mass of the oxygen, we can find that 2.4 grams of oxygen are 0.075 moles of oxygen. As from the equation given, we know that 2 moles of lead sulfate give 1 mole of oxygen. 0.075 moles of oxygen are produced by 0.15 moles of lead sulfate. Using the provided molecular mass of the lead sulfate, we can find that the 0.15 moles of this compound are 45.5 grams. The answer is C. On question 8, we are asked which volume of 18 mole per cubic decimeter of hydrochloric acid should be diluted to 250 cubic centimeters to prepare a 0.450 mole per cubic decimeter solution of hydrochloric acid. For a quick calculation, we can use C1 by V1 equals C2 by V2. Using the numbers given, as the units will be consistent, we can find that the volume is 6.25 cubic centimeters. The answer is B. On question 9 we are asked what is the number of ions in 4 moles of magnesium chloride. Each mole of magnesium chloride produces a total of 3 mole of ions, given by 1 mole of magnesium 2+ and 2 mole of chlorine minus. Therefore 4 mole of magnesium chloride produce 12 mole of ions and we will have 12 times the Avogadro number. This is 7.22 by 10 to the power of 24. And the answer is D. In question 10, we are asked about the correct explanation for the trend in the boiling points of chlorine, bromine, and iodine down the group. The boiling point is affected by the forces between molecules. Only D has an effect on the forces between molecules, therefore the answer is D. In question 11, we are given the equation of combustion of hydrazine and a table showing the standard enthalpy changes of formation for each of the substances involved in the reaction. We are asked what is the enthalpy change of combustion for hydrazine, giving the answer in kilojoules per mole. Using the reaction that the change of enthalpy of the reaction is the difference between the sum of enthalpies of the products and the sum of the enthalpies of the reactants, and the numbers given in the table, we obtain minus 555.8. The answer is A. In question 12 we are given 4 predictions and we are asked which one can be made using Le Chatelier's principle. Le Chatelier's principle says that if the equilibrium of a system is disturbed by a change in one or more of the determining factors, as temperature, pressure, or concentration, the system tends to adjust itself to a new equilibrium by counteracting as far as possible the effect of the change. Answers A and B mention the of catalyst. Catalyst is not mentioned in Le Chatelier's principle, therefore they are discarded. Only answers C and D mention factors that appear in Le Chatelier's principle, temperature and concentration. C is correct because the temperature has an effect on the reaction rate. D is not correct because the equilibrium position is constant. When the concentrations are changed, they adjust themselves to reach the same equilibrium. Therefore, the correct answer is C. In question 13, we are given 4 equilibrium reactions with the concentration of each gas in the equilibrium mixtures as 0.1 molar. We are asked which equilibrium has a numerical Kc value of 0.01. In this exercise it is faster to work with the calculator and scratch paper to have the right answer. Remember that you are not showing the work here. I just write here the equilibrium constant for the generic reaction between A and B to obtain C and D. Using a concentration of 0.1 for each substance and each equilibrium, we find that the answer is A. In question 14, we need to find out the number of sigma bonds in a given molecule. The sigma bonds are the main bond between carbon atoms and between carbon and hydrogen atoms. The secondary bond between carbon atoms is a pi bond. We have 3 carbon-carbon bonds and 6 hydrogen-carbon bonds, giving a total of 9 sigma bonds. The answer is D. In question 15, we are asked what is the number of hydrogen atoms in a given molecule. Writing the molecule with all the bonds and counting hydrogen atoms, we find that these are 12 and the answer is C. In question 16, we have the complete combustion of an alkane, forming 30 cubic centimeters of carbon dioxide and 40 cubic centimeters of water vapor, both measured under the same conditions of temperature and pressure. We are asked to find the alkane from the list given. We have that the proportion in volume of carbon dioxide to water is 30 to 40, or 3 to 4. As both gases are under the same conditions, this proportion is also valid for the number of moles. The number of moles carbon dioxide and water depend only on the alkane, not on the number of moles of the oxygen, and we can find these numbers using the complete combustion reactions of the alkanes. We don't need to adjust for oxygen. Remember that we are not tested by showing our work in section A. For butane, the proportion is 4 to 5. For ethane, is 2 to 3. For heptane, is 7 to 8. And for propane, it is 3 to 4. Therefore, it is propane. The answer is D. In question 17, we are asked to identify which alkene is an E stereoisomer from a given list. E stereoisomers are those with the highest priority groups attached to each carbon in the double bond are on opposite sides. To determine which groups have the highest priority, we use the Kenengold-Prelog priority rules. First, we compare the atomic numbers of the atoms directly attached to the double bonded carbons. The higher the atomic number, the higher the priority. Second, if the atoms are the same, we move to the next set of atoms along the chain until a difference is found. In alkene A, each of the carbons of the double bond are bonded to a carbon and to a hydrogen. Carbon take priority, and we can see that the highest priority groups are on the same side of the double bond. Alkene A is a Z stereoisomer. In the left-hand side of alkene B, we have the same situation than on the right-hand side of alkene A. On the right-hand side, we have that the carbon is attached to two carbons. So, we move to the next set of atom. On the top, we have two hydrogens and one carbon. On the bottom, we have three hydrogens. The top has higher priority. Alkene B is also a Z stereoisomer. In the left-hand side of alkene C, we have the same situation than on the left-hand side of alkene A. On the right-hand side, we have that the carbon is attached to two carbons. Again, we move to the next set of atom. On the top, we have three hydrogens. On the bottom, we have three carbons. The bottom has higher priority. Alkene B is also a Z stereoisomer. In the left-hand side of alkene D, we have the same situation than on the right-hand side of alkene A. On the right-hand side, we have that the same situation than on the right-hand side of alkene C. Alkene D is the E stereoisomer. The answer is D. Moving to question 18. When heated with aqueous sodium hydroxide, 1-chlorobutane is hydrolysed at a slower rate than 1-bromobutane. Which of the given four statements explains the different rates? These are substitution reactions of an alkene by a hydroxyl group via nucleophilic substitution SN2. We are breaking a halogen carbon bond and forming a hydroxyl carbon bond. The stronger the bond between the halogen and the carbon, the longer it takes to break. The strength of this bond is given by the bond enthalpy, therefore options C and D are not applicable. As we know that 1-chlorobutane is hydrolysed at a slower rate than 1-bromobutane, its bond enthalpy is higher. Therefore, the answer is B. In question 19, we are given a spectrum and we need to identify which compound of four compounds given could have produced the spectrum. From the data sheet provided in the exam and looking at the spectrum, we see. First, there is a peak between 2800 and 3100 reciprocals per centimeter, indicating a possible alkyl group. Second, there is another peak at around 1725 reciprocals per centimeter. This is the region of the double bonding of carbon and oxygen. Compound A is a ketone and the double bonding of carbon and oxygen should give us a peak between 1630 and 1820 reciprocals per centimeter, and we have a peak just around 1725 reciprocals per centimeter. We can also see the peak due to alkyl groups. A is a possible answer. B is an alcohol, and the oxygen-hydrogen bond should give us a peak between 3200 to 3600 reciprocals per centimeter. But we do not observe peaks in this region. B is not an answer. C is a ketone with an alcohol group. As we have seen for B, the alcohol group is not observed and therefore C is not the answer. D is a carboxylic acid. We should expect a broad peak in the region 2500 to 3300 reciprocals per centimeter due to the oxygen-hydrogen bond, but the peak observed is not broad, so D can be discarded. The only option left is A. The answer is A. In question 20, we are given a set of alcohols and we are asked which one is likely to have fragment ions at Mz ratios equals 15, 29, and 43 in its mass spectrum. These exercises are trial and error until you find the correct breakdown of the molecules to obtain the relevant Mz ratios. Unless I see clearly from the beginning, I would leave this question to the end. For this particular exercise, I have not found Mz ratios of 43 for any component except for option C. M equals 15 are CH3. They are present in A, B, C and D. M equals 29 are CH3CH2. Also present in A, B, C and D. M equals 43 are CH3CH2CH2. Only found in C. C is the answer. We now start with section B. In question 21, we have an alkene. In question A, part 1, we need to say the systematic name of the alkene. The displayed formula of the molecule shows a chain of 4 atoms of carbon. This is a but. Starting numbering from the double bond, to provide the lowest numbers in the name, we get a but, 1, Ene. In the carbon number 3 we have 2 methyl groups. We can name the compound as 3,3-dimethyl but 1,Ene. In question A, part 2, we are asked about the reaction of the alkene with bromine. This is an example of addition of a halogen, bromine, to an alkene via electrophilic addition. As the bromine and 3,3-dimethyl but 1,Ene, molecules approach each other, the area of high electron density around the double carbon-carbon bond repels the pair of electrons in the bromine-bromine bond away from the nearer bromine atom. This makes the nearer bromine atom slightly positive and the further bromine atom slightly negative. In this first stage we need 2 curly arrows, the first curly arrow from double bond to a bromine of the bromine-bromine bond and the second curly arrow for breaking the bromide bond. As the new bond between the carbon and the bromine atoms form, the bromine-bromine bond breaks heterolytically. The bromine minus ion formed then attacks the highly reactive carbocation intermediate. So one bromine atom bonds to each carbon atom. The product obtained is. In question 21b, we have 2 questions about the polymerization of the alkene given in question 21a. In the first question we are asked to draw a repeat unit of the polymer. This is an example of addition polymerization of an alkene, involving the breakage of the pi bond in each double carbon-carbon bonds, then the monomers link together. In the second question, we are asked to state one advantage and one disadvantage of using combustion as a method for the disposal of a polymer after it has exceeded its useful life. The advantage is that it produces energy or electricity. You can also say that it reduces the consumption of fossil fuels. The disadvantage is that produces greenhouse gases contributing to global warming. Question 22 is about atomic structure and formulae. In part A, we are given the mass spectrum of osmium. We are asked to calculate the relative atomic mass of osmium in the sample, giving the answer to 2 decimal places. The relative atomic mass can be calculated by adding all the results obtained by multiplying each relative atomic mass by its percentage and dividing the total by 100. Replacing the numbers given, I get 190.4677. Rounded to 2 decimal places, I get 190.47. In part B of question 22, we are given a table of 2 different elements. We need to complete the table with the symbol or name of element, the mass number, number of protons and neutrons, and the electron configuration. We get a point for each correct row. Starting for the second row, an atomic number, that means the number of protons, is 28. From the periodic table in the data sheet, we can see that it corresponds to an atom of nickel. The mass number can be calculated by addition of the number of protons and neutrons, 28 plus 34 equal to 62. We know that the charge is 0, therefore, the number of protons and electrons is the same, meaning that the number of electrons is also 28. We can fill an energy level diagram until we reach a total of 28 electrons. If you fill the diagram, you will get one of these 2 answers, both acceptable. Note that an alternative method is to use the periodic table to fill the energy level. In the third row, the electronic configuration indicates a total of 2 plus 2 plus 6 plus 2 plus 6 equal to 18 electrons. As the ion has a charge of -3, there are 3 electrons in excess, thus the number of protons is 18 take away 3 equal to 15. From the periodic table, we find that atomic number of 15 corresponds to phosphorus. The number of neutrons can be obtained by subtracting the number of protons to the mass number, 33 take away 15 equal to 18. In part C of question 22, we are given the percentage composition by mass of a hydrated salt. We are asked for its empirical formula and its formula showing the water of crystallization. To calculate the empirical formula, I always create a table with 5 columns. The first column is for the name of the atom. The second column is for the atomic mass. The third column is for the mass of percentage of each atom. In the 4 column I calculate the number of moles by dividing the mass with the atomic mass. In the last column, I divided each number obtained in the previous column by the lowest number obtained in the previous column. The first column and third columns are filled with the data of the problem. The second column is filled with data from the periodic table. The fourth column is the division between the third and the second. In this, lowest number obtained in the fourth column is 0.336. So, in the fifth columns we divide each number obtained in the fourth column by 0.336. The numbers obtained in this column give us the empirical formula. That is 1 atom of zinc, 12 of hydrogen, 2 of nitrogen and 12 of oxygen. To find the formula showing the water of crystallization, we need to consider that as the salt is hydrated, the water content has been included in the empirical formula. The proportion hydrogen to oxygen is 2:1. In the empirical formula we have 12 atoms of hydrogen and 12 atoms of oxygen. Considering that all the hydrogen is provided by the water of crystallization, we have 12 divided by 2 equals 6 molecules of water, that will use 6 atoms of oxygen, leaving available 12 minus 6 equal to 6 atoms of oxygen in the salt. Therefore, the formula showing water of crystallization is 1 atom of zinc, 2 atoms of nitrogen, 6 atoms of oxygen and 6 molecules of water. Question 23 is about different types of bonding. Part A has 2 questions. The first question asks the definition of ionic bonding. Ionic bonding is electrostatic attraction between oppositely charged ions. When magnesium reacts with sulfur, it forms magnesium sulfide with formula Mgs. The magnesium ions have a charge +2 and the sulfur ions have a charge -2. We just need to complete the diagram by alternating these two ions. In part B of question 23, we are provided with the definition of oxyanions, and we are asked to complete a table of oxyanions. Starting with the second row, with the bromine and oxygen ion, we can deduct that name is going to be bromate. To calculate the oxidation state, we consider that the oxidation state of the oxygen is -2, 2 atoms of oxygen will produce a net charge -4, but the oxyanion has a net charge of -1, therefore, the bromate only neutralize 3 negative charges, making it bromate 3. In the last row, we have phosphate with an ionic charge -3. We know that the formula is going to have phosphorus and oxygen. We fix the number of atoms of phosphorus to 1 and the number of oxygen to an unknown x. If this number x results in a fractional number, we will amend the atoms of phosphorus accordingly to have whole numbers of oxygen. The atom of phosphorus has a charge contribution of +5. Each atom of oxygen has a charge contribution of -2, and x atoms of oxygen will have a contribution -2x. The total charge contribution of phosphorus and oxygen is going to be the ionic charge, that is -3. If we solve the equation, we find that x equals 4. Therefore, the ion is made by an atom of phosphorus and 4 atoms of oxygen with 3 negative charges. In part C of question 23, we are asked to describe the structure, bonding and electrical conductivity of calcium in the solid state. We may include a diagram. The key points and words are: first, it is a large structure. Second, it is metallic bonding. Third, the electrical conductivity is due to the movement of electrons. Fourth, it can be considered as a structure of ions of calcium 2+, and surrounded by delocalized electrons. A diagram will help. I would write something like: calcium can be considered as a large structure of ions of calcium 2+, with the 2 electrons of valence delocalized between the calcium ions. The movement of these electrons explains the electrical conductivity of the calcium. Question 24 is about halogens, and practical tests. Part A is about the reaction of chlorine gas and dilute sodium hydroxide, mentioning that this is a disproportionation reaction. In Part 1, we are asked about the definition of disproportionation. It is an oxidation and reduction of the same element. This is a classic disproportion reaction. We know that the chlorine gas, with oxidation state 0, is going to form ion chlorine -1 and chlorine +1. The chlorine cation is going to be in the form of sodium hypochlorite, NaClO. As we are using sodium hydroxide, NaOH, we can safely consider that the anion chlorine is going to form sodium chloride. I know that it is in aqueous sodium hydroxide and the products are going to be dissolved, but for the reaction purposes, we can consider them as solids. The equation is this. And the explanation is: chlorine is going to be oxidized from oxidation state 0 to +1 in the sodium hypochlorite, and reduced from oxidation state 0 to -1 in the sodium chloride. In part B of question 24, we are informed that a student is supplied with aqueous solutions of ionic compounds B and C. We know that compound B is a chloride, bromide, or iodide of a group 1 element, meanwhile compound C is a chloride, bromide or iodide of a group 2 element. Their molar masses are both in the range 100 to 115 grams per mole. We are asked how the student could identify the halide present in B and C and their formulae. A typical identification of halides involve the addition of silver nitrate in nitric acid followed by addition of ammonia. Addition of silver nitrate in dilute nitric acid produces a precipitate of the halide nitrate. The color of the precipitate allows to identify the halide. In the case of chlorine, the precipitate is white, in the case of bromine is cream, whereas in the iodine is yellow. In practice, these colors can be difficult to differentiate between each other, and there is a second step to identify the halide by the addition of dilute ammonia, that dissolves the silver chloride, and the addition of concentrated ammonia, that dissolves the silver chloride and the silver bromide, but not the silver iodide. However, in the marking scheme mentioned that this step with the ammonia should be ignored. With molar masses in the region 100 to 115 grams per mole, we have only two possible options: sodium bromide with molar mass of 103, and calcium chloride with molar mass 110. All the other possible halides are outside this region. Question 25 is about enthalpy changes and reaction rates. In Part A, we are given an aqueous reaction between barium hydroxide and dilute nitric acid to produce barium nitrate and water. A student carries out an experiment to determine the enthalpy change of the reaction by measuring out 25 cubic centimeters of 2 molar barium hydroxide and 50 cubic centimeters of 2 molar nitric acid. Both solutions, at the same temperature, are mixed in a polystyrene cup, the mixture stirred, and the maximum temperature recorded. In the first question, we are asked the enthalpy change of the reaction, giving the answers to three significant figures and assuming that the density and specific heat capacity of the solutions are the same as for water. We consider that there is no change in volume when both solutions are mixed, good approach unless otherwise stated. The total volume of the solution is 75 cubic centimeters. 25 of barium hydroxide plus 50 of nitric acid. As the density of the water is 1 grams per cubic centimeter, the mass of the solution is 75 grams. The energy required to the increase as the product of the mass of water, the specific capacity of the solution, and the increase in temperature. This is the energy for the whole reaction, but we need to refer to the reaction in number of moles. The first step is to calculate how many moles we have of each reactant. This can be found by multiplying the concentrations by the given volumes, with the right units. We can see that for barium hydroxide we have 0.05 mole and for nitric acid we have 0.1 mole. The concentrations are in stoichiometry proportions, none of them is in excess, and the number of mole of barium nitrate is the same than the number of mole of barium hydroxide, that is, 0.05 mole. As we know that the energy produced these 0.05 mole is 5799.75 joules, we can calculate that enthalpy of the reaction is 5799.75 joules divided by 0.05 mole is 115,995 joules per mole. Expressed in kilojoules per mole and three significant figures, we have 116 kilojoules per mole. One final point: as the reaction is exothermic, the enthalpy is negative. In the second question in section A, of question 25, we are asked why the enthalpy calculated in the previous question is not the enthalpy change of neutralization. The answer is that the enthalpy change of neutralization is the enthalpy change when 1 mole of water is formed by the reaction of an acid with an alkali. Equation 25.1 refers to 2 mole of water. The enthalpy change of neutralization should be half of the value calculated, that is, 58 kilojoules per mole. The marking scheme does not penalize for using the wrong sign. In Part B of question 25, we are provided with the Boltzmann distribution for a gas at room temperature. We are asked to label the axes on the figure, add a second curve to show the Boltzmann distribution of the gas at a higher temperature, and explain why the Boltzmann distribution shows that the rate of a reaction is affected by temperature. Boltzmann distribution is a plot of number of molecules versus energy. Filling the label of the axes is straightforwards. A curve at higher temperature will need to: first, start close to zero. Second, do not touch the x-axis at high energy. Third, have a maximum to the right but lower than the provided curve n. Fourth, Finish higher than the provided curve. The Boltzmann distribution shows that an increase in temperature will increase the number of molecules that have energy greater than the activation energy, and therefore more molecules will have enough energy to react. Question 26 is about haloalkanes. In part A, we are asked the mechanism of the reaction for 1-chloropropane hydrolysed with aqueous sodium hydroxide. We are provided with the structure of the 1-chloropropane. Hydrolysis of the 1-chloropropane is a nucleophilic substitution SN2. The carbon-chlorine bond is polarized because the chlorine is more electronegative than the carbon. Therefore, the carbon atom carries a partial positive charge as the electron pair in the carbon-chlorine bond is drawn nearer to the halogen atom. The OH- ion donates a pair of electrons to the partially positive charged carbon atom, forming a new covalent bond. At the same time, the carbon chloride bond is breaking. The chlorine atom takes both the electrons in the bond and leaves as a chlorine- ion. Remember to clearly show that the products are ethanol and chlorine-. In question 26, part B, we are given a bromoalkene that is liquid at room temperature and pressure, but can easily be vaporized. When vaporized, 0.33 grams of the bromoalkene produces 74 cubic centimeters of gas at given pressure and temperature. We need to determine the molar mass and molecular formula of the bromoalkane. Using the ideal gas equation and making the number of moles the subject, remember to convert cubic centimeters to cubic meters and Celsius to Kelvin. We get 2.41 times 10 to the power of -3 moles. As we know that the mass is 0.33 grams, we get a molar mass of 136.9 grams per mole. As bromoalkene, the molecular formula is N atoms of carbon, 2 times N plus 1 atoms of hydrogen, and 1 atom of bromine. Replacing the molecular masses of each atom and making it equal to the molar mass, we have the following equation. And find that N is equal to 4. Therefore, the formula is C4, H9, Br. And this is the end of the paper.